Guys, what we're doing now in exercise 14.1 is the second derivative. Now, the first derivative is written down like this, dy dx. The second derivative is d2y dx squared. Do not get worried about where the 2's are. Does that mean d squared? Does that mean x squared? It doesn't, alright? All what it means is, when you see that, differentiate twice. So let me give you an example. The first question I'm going to do here is question 26, okay? Now in question 26, we're just going to move down the two of these for a minute. And then what we're going to write down is the usual. We now have y here, which makes the whole process a bit easier, right? Y equals x squared minus x4. Step 1, dy dx means the first derivative, differentiate. 2x, then minus 4x to the power 3. Second derivative means differentiate your answer. When you differentiate 2x, you get 2. When you differentiate 4x cubed, you get x squared. Okay? Minus 12x squared. Guys, next thing, okay? What we're looking at here is that's the question 26 done. Now we're going to go to a more difficult one. Example of a more difficult one might be question 32. Now guys, 32 changes into 8x to the power of a half minus x to the power minus 2. That's your first stage of prep. Now that all the powers are on top and you have no more fractions, you can now differentiate. Differentiate the first time, you're going to get a half times 8, 4, a half minus 1, minus a half minus 1, minus a half, minus 1 times minus 2, plus 2, take away 1 from the power, minus 3. Differentiate a second time is what this means. Now what we're going to do is minus a half times 4, minus 2, take 1 away from the power, minus 3 over 2, minus 3 times 2, minus 6, take 1 away from the power, minus 4. There's your answer. Okay?
So would you differentiating that like crazy?
So, next one is question 37, 38 and 39. Okay? So, these ones here, okay, what they want you to do is, they'll ask you for instance 37, okay? Now this is an example, I'm going to give you real life context to this. S is usually the distance covered by an object, okay? And S, because it's a minus, if I was to show you this in graph form, okay? Sorry guys, it's 3t minus 2t squared. I'm just going to give you a bit of background context here, okay? If you were to draw a graph of this, okay, what would happen is this. You'd say f of x equals 3x minus 2t squared. This is actually nothing about the question at the moment, it's just adding context to what's going on. Now, what happens is, if I say it starts at 0 and ends at, let's say, 10. Now what happens is, I'm getting the s value is f of x and the x value is time. So what this means is if I throw an object, it covers, at time 0, it's covered no distance. At time 1, it's gone 1 meter into the air. At time 2, it's now 2 meters below where it started. At time 3, it's now 9 meters below. So let me give you a context. This could be a question where a man throws a ball off the edge of a cliff. The ball starts off at level ground, s equals 0. At the end of 1 second, which is t equals 1, it's 1 meter into the air. So at t equals 1, it's 1 meter into the air. However, at t equals 2, where's the ball located now? Minus 2. So it's 2 meters below, so it went up and then went back down again. That's the sort of context questions they can do. Now, what they might ask you is this, okay? S is the original value. S is a formula in terms of t. In the same way we had y in terms of x. Now the first question it's going to ask us is differentiate s with respect to t. You treat the t's like you did x's. So what's the answer for the first one? Differentiate 3t? 3t. Oh, sorry, 3. And this one here?
4 minus 4
minus 4t. Now guys, if s is the distance, the first derivative is the velocity. This means you can find the velocity by using the first derivative. The second derivative is going to be acceleration. Now you're going to find this in a further on chapter, okay? Not at the moment, so I'm just adding a bit of context. You can differentiate a second time. What do we get? Minus 0 and minus
4.
So it's always minus 4. Now what they're going to ask you is in the question to go find the SDT. Okay, the SDT is they're both when t equals 2. So what's the SDT when t equals 2? It's going to be 3 minus 4 times 2, which is now that's what we know, because remember I said the ball is dropping underneath. It means its velocity is negative because it's dropping. Does that make sense? Now the other one, the second derivative is minus 4, but there's no t value to put in, is there? So the answer is just minus 4. Okay? I'll do one more of these because I think these are where you might get a bit stuck, okay? We'll try another one. If a is pi r squared, find dA dr. So, okay, what type of number is pi? Is pi a variable or a constant? Constant. So you treat pi like you would a regular number, okay? If I ask you to differentiate 5r squared, what would you tell me the answer is? Oh, sorry, just 5r squared, not 5 pi r squared. 5r squared, what would you tell me the answer is? You tell me the answer is 10r, because you'd multiply 2 by 5 and you get 10. I'd like you to do the same thing. Multiply 2 by pi and we get 2 pi r. Okay? Now the next thing is when r over 5 equals 1. Okay? We haven't got r over 5, we simply have r. So what we're going to do is we're going to cross multiply up to 5. We're going to get r equals 5. And now we're going to replace r with 5. So we're going to get 2 pi times 5, which is 10 pi. Okay, the last part of this exercise, one of the toughest questions in it. Okay, what it says is if y equals 4x cubed minus 6x squared, show that x squared multiplied by the second derivative minus 2x multiplied by the first derivative minus 12 times x equals 0. What we have to get first is the first derivative. Okay? So what we're going to get is 2y dx equals, anybody? 12x squared. 3 by 4, 12. Take away the 1, 2. 2 times 6 minus 12x. Differentiate again. 24x minus 12. Stop there. Now what we got to do is we got to fill in our equation. Okay? X squared times the second derivative, which is 24x minus 12, minus 2x times the first derivative. Okay? Minus 12x equals 0. Now what we get here, guys, is this. X cubed times 24x for x cubed. X squared times minus 12 minus 2x times minus 12x squared minus 2x times minus 12. Okay. Plus 24 x squared. Now minus 12x. Alright. Now I'm going to cancel them. Now I think, right, 24x squared, 24x squared. I think I made a mistake. I think the question meant to read 12x squared. I'm going to tell you why. it doesn't equal 0 at the moment because 24x squared minus 12x squared doesn't cancel. And if that was 12x, it doesn't cancel. And the reason why I know, it's a show that question. If it said investigate if, what would I say? Yeah, but it says show that. Show that means it has to work, which in my term means the logic is that the book should have said squared.
Yeah, but even if it was 12x squared, it wouldn't even.
It will cancel. Oh, sorry, minus 12x squared. No, just give me. Yeah. Minus 12x squared plus 24x squared cancels. 0 equals 0. Take down that modification on question 44 now. Now lads, what I also asked is find the values for which the first derivative equals 0 and the second derivative equals 0. Okay? When the first derivative equals 0, here's what we have. Okay, you can open the way there, guys. Now, what happens next is 12x squared minus 12x. What we need to do is we need to factorize, okay? 12, take 12x out, put x minus 1 inside equals 0, because it asked me to put the full thing equal to 0. Solve it. Either means the number outside equals 0, or the number inside equals 0. So x equals 1, or x equals 0. For the second derivative, it's a lot easier. Bring 12 over. 24x equals 12. X equals a half. Okay, guys?